So we're going to be looking at two pretty important vocabulary words this weekend. One is discrete, one is continuous. And so I just want to go ahead and graph these and then we'll talk about it. For the functional relationship described, sketch a graph with the independent and dependent axis labeled with words. Determine a reasonable domain and range for the function, then tell whether the function is discrete or continuous. So my first situation is the altitude of a punted football depends on the number of seconds since it was kicked. Okay, now remember we've done independent and dependent, so the altitude depends on the seconds. So this is my dependent, which means it's my y variable. This is my independent, which means it's my x variable. So let's go ahead and at least draw the x and y, seconds, and altitude. So let's just put points on here. Okay, at 0 seconds it wasn't kicked. Okay, at 1 second it was going up. At 2 seconds it was going up. At 3 seconds it was going up. At 4 seconds it's going up, but then it's going to start coming back down. Now the question I always ask myself is it kicked in the air? Does it have an altitude at 1.5 seconds? Well, of course it is. Okay? It has an altitude at every millisecond pass. So the path of this would look like this. Okay? And a reasonable domain and range. Since this is all continuous, okay, I can't list all these points. I'm going to use interval notation. So our domain, and we're just going to pick numbers, okay? So we're going to pick that this altitude got to, I don't even know how high a football goes, so 50 feet in the air. And it took, we'll say, 10 seconds to reach the ground. That might be totally ridiculous, but that's what we're going to go with. Okay, so domain, remember, is from left to right. So domain, my smallest, my largest. And since I have points there, it's going to be a bracket. Range is bottom to top. And the top we said was 50. So my reasonable range is going to be from 0 to 50. And again, we're going to use brackets. Okay, so let's talk about this. The number of used aluminum cans you collect and the number of dollars refunded to you are related. So we have to figure out the dependent and independent first. So the cans I collect and the number of dollars. Which depends? The cans collected depend on the money, or does the money depend on the cans collected? Well, I know that my money is dependent on how many cans I collect. So this is my dependent, which means it's my y. This is my independent, which means it's my x. So I'm now going to draw a graph. This is going to be the number of cans, and this is going to be the money. And I'm going to say for every 1 can, I get 50 cents. Every 1 can, I get 50 cents. A second can, I get $1. A third can, I'm going to make $1.50. And so on and so forth. Okay. So now the first question we ask is, can I put in 1.5 cans? Can I put in 1.5 cans? Well, no, I can't. I can't do 1.5 cans. So this is not I don't connect all these dots. These dots stay separate like this. I don't do 1/2 of a can or 2 1/3 cans. I just do 1 can or 2 can. Okay, so let's come up with a reasonable domain for this. Now, remember, these are individual points. And we're going to say we're going to return 20 cans. Okay, so domain, if I'm listing points, remember I have to use list notation. So I could do anything from 0, and I don't want to list all the way to 20, so I'm just going to do this. And range is the same thing, but I can make 0 money, I can make 50 cents, I can make $1, all the way up to $10. That would be my range. Now let's talk about these huge words, discrete and continuous. Discrete and continuous. So it should look relatively easy. If my graph continues, it's continuous. If I have individual points like I do on this graph, this is going to be discrete. So the question is always, can I have half? That's how you determine if it's discrete or continuous. If you can have half, pretty much it's going to be continuous. If you can't do half, like I can't turn in a half of a can, then it's going to be discrete. So I'm going to start with the number 4 first. So the grade on your test, as a function of the number of questions, you answer incorrectly. Note, this teacher does not believe in partial credit. There are 20 questions on a 100-point test, so that means each question is worth 5 points. 5 times 20 gives me the 100. So each question is worth 5 points, and I don't give partial credit. So the grade on my test depends on the numbers I answer incorrectly. Okay. So the grade is my dependent. And this is the number incorrect. Okay. If I get 0 incorrect, my grade's going to be a 100. If I get 1 incorrect, my grade's going to be a 95. If I get 2 incorrect, my grade is a 90. And I think you can see what's happening here. Can I ever get a 93? This teacher doesn't do partial credit, so it's 5 points or it's no points. So I am never going to be able to get a 93 or a 99.9. So this would be my graph. I would not continue it. I would just have individual points all the way down to 0. How many do I have to get incorrect to get a 0? All the way down here to, if I get 20 incorrect, I get a 0 on the test. So let's talk about domain and range. These are points, so I'm going to have to list them. So my domain starts at 0 incorrect, 1 incorrect, 2 incorrect, all the way up to 20 incorrect. My range, now typically you're going to want to start at 100 because that's the first grade we talked about, but remember range is smallest to largest. So the lowest grade I can get is a 0. I can get a 5 by only getting 1 right. I can get a 10 and all the way up to 100. And this would be discrete. So now let's look at number 3. Well, it's talking about a grade again. Okay, so we're talking about grades, number of questions I answer correctly. So the number correct. And this is my grade. Well, if I answer 0 correct, I get a grade of 0. If I answer 1 correct, 100% correct, because see, these are still 5 points, but this teacher does partial credit, and we'll talk about that in a minute. If I get 100% correct, I get a 5. If I get 2 correct, I get a 10, for sure. So you can see what's happening here. Now, what if I get some partial credit on question number 1, and she gives me 3 points partial credit? So I could actually get 1.5 questions right and get an 8. Okay? I could get a half a question right and get a 3. So when I'm talking about continuous and discrete, this graph down here is obviously discrete because I can't get anything but 5 points for a question. Now we have to ask ourselves the question here, do we connect these dots? I know they're going to get closer and closer, but remember right after 0 is 0.00000001, 0.00000002. Do I get to a point where I'm going to connect this line so that I can get any grade between 0 and 100? So I could get a 99.99999999. I don't think teachers would ever do that. So I know my highest grade is going to be a 100. And I know that would be 20 points, 20 questions answered correctly. Okay. Now, the domain and range are this going to be tougher since these are individual points. I still can get 0 right. I can get a half right. I can get a fourth right. I haven't ever seen a teacher give less than a fourth, so we're going to go with a fourth. So I can get 0 right, a fourth right, a half right, 3/4 right, 1 right. And I'm going to follow that pattern all the way up to getting a 100. No, all the way up to, I'm doing domain now, all the way up to 20 questions. Range, so I can get a 0. If I get a fourth of a question right, that's such a weird number. So it's like, instead of 5, it's like I get 1 point right. I can get 2 grade, I can get a 3 grade, I can get a 4 grade. And I'm going to go all the way up to a 100 possible points on this test. I don't think anyone would ever give a grade of a half. So that would be your domain and range. And again, this would be discrete. So let's look at what graphing in discrete looks like. Graphing discrete and continuous. In this problem number 5, it's saying graph this, but only use those for domain. And we know domain is x. So I'm going to make a table. I'm going to put those numbers in. I'm going to plug them into my function for x. So if I plug -2 in, I get -3. If I plug 0 in, if I plug 2 in, if I plug 4 in. Those are the only 4 points that I'm going to put on my graph. So -2, -3, 0, 1, 2, 5, and 4, 9. Now let's look at this one. This one is saying graph this function, but use any numbers greater than or equal to 1. Now this is just like a piecewise, it's just one piece. Okay? I actually think using a table in this case is easier, so I'm going to start with 1 and go to 2 and go to 3, and this will continue on forever. If I plug 1 in, I get 3. If I plug 2 in, I get 2. If I plug 3 in, if I plug 4 in. Okay? So 1, 3, 2, 2, 3, 1, 4, 0. You can see what I'm doing. So I could put this whole line in here, like we're so used to doing. But it says it only wants you to go, oh, again, that was weird, 1 and greater. So it only wants the graph greater than or equal to 1. So I need to erase off this part of my graph. Oh, good. It's not going to let me erase. So I don't want this part of my graph. So I'm going to go all the way over here to 1. Okay. And it wants me to start at 1, 3. So it will just look like this. Okay? All right. Hope you guys had a really safe homecoming weekend, and we look forward to seeing you on Monday.